Hello everyone, this is Adel from OS Engineering, and in this video I'll show you how to solve for DC and AC inductance in Ansys Q3D. Let's consider this very simple geometry where we have two groups of cables. Let's assume this is positive and this is negative. And we want our signal to go from this side of the positive and come back from here. So we will assign our sources and sinks accordingly. This side will be sources, sinks, sources, and sinks. Here the first thing to do is to go to nets, right click on it and select auto identify nets. Here under nets we can see now all our nets. Now let's assign our sources and sinks. First let's switch to the select face mode. We can do that by clicking on the F key on the keyboard, or we can go here and select face. So I'll select the first one, right click, go to assign excitation and select source, then we click OK. On the other side of the cable we'll do the same operation. Let's select the face, right click, assign excitation. This time we'll select sync and click OK. Now we will do the same with the other cables. For the second group of cables, we will assign the source here. Right click, assign excitation, source, okay, and we will assign the sink here. Then we will do the same with the other cables. Now if we go here in the project manager and expand the nets, we can see the sources and sinks. Now the next step is to go to reduce matrix. We want these four in parallel, these four in parallel, and then connect them in series. So if I right click on reduce matrix, I can go to join in parallel and select the sources of the first group of cables. So I select source 1, source 2, 3, and 4. Click save and create. And then I'll select the sources from the second group of cables. And here I click save and close. Let's rename this parallel. And I'll make a copy of it. Right click here and click duplicate. And I'll rename this one series. In this one, I'll right click on it and I'll go to join in series and connect sync 1 to source 5 and click save and close. We can go here and clear this error message. And the next step is to create a solution setup, which I already did. Here I'll solve this model at 10 MHz. For the solution selection we need DC and AC. And here I have a frequency sweep from 0 to 1 kHz, 101 points, linear count. And from 1 kHz to 40 kHz, 40 samples. That's log scale. Now let's go to the design name, right click on it, and click Analyze All to solve the model. Once the model is solved, we can go view the results, but first let's check the mesh. So I'll select the cables, right click and click plot mesh. Here I click done. And as you can see, we have good mesh. Now let's go and look at the inductance results. So I'll right click on results and click solution data. Here at 0 Hz we have the DC inductance for the individual cables. To view the self terms we can click here. And to display the AC inductance, we'll just change the frequency. I'll select 40 kHz, and this is the AC inductance for the individual cables. We can also plot the results, so I right click on results, create matrix report. Here I'll change the matrix and select parallel, and I'll plot the DC solution for the partial inductance of each group of cables. Here I'll make a new report where I select AC, and I'll plot the self-inductance of each group of cables. Here we can use logarithmic scale, so I can go to X scaling and change it to log, click apply, OK. And here's the DC solution. Now let's plot the DC solution for series inductance of all cables. I change this to series. And here we click new report. Let's also plot the AC solution. So I select it and click new report. Here we can use log scale. And here's our DC solution for the series inductance. Now let's plot the fields. So I'll double click on the design name. And here let's hide the mesh. So right click on mesh and click plot visibility. Here with the select face mode, I'll select all the cables. Right click, select DCRL fields, and here we'll plot the current distribution. Here let's click done. Here it looks like we are exciting only one cable, so let's go to field overlays, right click there and click edit sources. Let's select the DCRL tab, and here we can change the value for all sources to 1 ampere. Let's click OK, and the plot will automatically update. Now let's plot the AC solution for current distribution. First, let's hide the DC solution. So let's expand this, right click here and click plot visibility. Now let's select all the cables, right click, go to ACRL fields, and let's plot the current distribution. Here let's click done. Same as before, to edit sources, let's go to field overlays, right click on it, go to edit sources, and select the ACRL tab. Here we can change the value for all sources. And let's click OK. The plot updates automatically. In this video, we saw how to solve for both DC and AC inductance using Ansys Q3D. Thanks for watching, and see you in the next video.